Hello students, good evening everyone. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, our chemistry faculty from Infinity Learn. And I hope I am perfectly audible and visible to each and everyone present over here to watch this particular session. So those who are watching the session, just mark your attendance here. Just give me hi in the comments. So in the last 2 and 3 sessions, we have completed our revision of the 3 chapters, right? First chapter, we have already completed chemical reactions and equations, right? So chemical reactions and equations, we have revised it through some topics, some questions based on that. Then we have discussed about the second chapter, acid, bases and salts, right? Acid, base and salts. We have already discussed many important topics through the questions. Then we have completed our fourth chapter, carbon and its compounds, right? So today we are going to discuss about the revision part of the metals and non-metals, our third chapter from the syllabus, through some questions. Mainly we are focusing on the metallurgy part over here. As we already know, I have already completed the concept classes, right, in the case of metals and non-metals. So what we have studied? We have studied about what we mean by metals, non-metals and metalloids, right? And we have seen the physical properties of metals and non-metals. Similarly, we have studied about the chemical properties of metals and non-metals, right? So we have seen the reaction with oxygen, reaction with water, reaction with hydrogen and so on. So we have seen the type of oxides formed by the metals and non-metals also. And then what we have studied? After that, we have studied about the one important part of the metals and non-metals, that is about the metallurgy, right? Currently, we are going to discuss only about the basic part of the metallurgy, but it is very important in your grade 11 or grade 12 classes, metallurgy part, right? Metallurgy part. So here I have already prepared around 15 questions, I think. So from the topics, metallurgy, mainly focusing on the metallurgy. In the metallurgy part, we have already discussed what do you mean by the metallurgy process, right? We are just extracting the metal from the ore, right? Metal from the ore or minerals. So we have seen many of the methods like the extraction of metals, purification of metals, and reducing the metal oxides, right? So based on the part, we are going to discuss the questions. So I hope we can start the session now. We're starting from our first question. So whenever we are discussing about the physical properties of the metals and non-metals, we have discussed about the formation of ionic compounds, right? Formation of ionic compounds. So as we already know, whenever we are discussing about the ionic compounds conduct electricity, right? They can easily conduct the electricity in their specific state, that if they are on the solid state, gaseous state, or molten or aqueous state, or only in polar solvents. So is there anyone watching the session? Just give me the answers in comments. Okay, ionic compounds we have already seen, right? Cations and anions are forming. Metals are losing the electrons to form the cations, and non-metals are gaining the electrons to form the anions. So they are forming an ionic compound, right? Nimish, we have started just now only. Here is our first question. Hi, good evening all of you. Okay, what is the answer for this question? Ionic compounds conduct electricity in their solid state, gaseous state, or their molten or aqueous state, or only in polar solvents. So what will be the answer? So no one is responding, so I will give the answer. Okay, fine. Option C is the correct answer, right? So option C is the correct answer in their aqueous state or the molten state. Yes, Nimish? Nimish, right? Yes, you are correct. So what do you mean by the aqueous state or molten state? There will be free ions are possible, right? Free ions are there in the state. So it is easily conduct electricity. They will be producing electricity because of the presence of these free ions, or the mobility of ions are maximum in their gaseous state or molten state. Okay, I hope you understand about the first question, right? Now we are moving to our second question. The question is based on the metallurgy part. So here is the question. The hand picking is not effective when? ore and impurities are different in size, impurities are magnetic, ore and impurities look alike, impurities are floating. So we have already discussed different methods to separate the ores, right? Okay, Nimish, we have already completed the concept classes for the chapter. Just after the session, just revise the recorded session, and you will get the idea about the classes, right? Here we are going to revise the such questions. Okay, this is a metallurgy part, right? Metallurgy part in the metals and non-metals chapter. We have already completed the chapter. So in the end of the session, I have already discussed about the metallurgy part. So what do you mean by the metallurgy? As we already know, in the case of metals, there will be ores and minerals are formed, right? In some of the cases, minerals will be having some percentage of metals in it. So we need to extract or we need to purify those metals from the metal ores. So such a method is known as the metallurgy part. So we have already discussed different methods to separate the ores and impurities, right? So hand picking is one of the method for that. Okay, just rewatch our session, then you will get the correct idea about that. I have already given the complete concept class over the metallurgy part. So here I will give the answer here. Option C is the correct answer, right? Ore and impurities. So as we already know, ore particles means in which they are containing some percentage of the metals, right? For example, if I am taking iron oxide, right? There is an ore like magnetite or hematite. This is also we have discussed in the beginning of the session, right? Magnetite is an ore of iron. So if I want to extract or if I want to separate the iron metal from these ore, I am doing some of the method, right? I am doing some of methods. So first method is known as the hand picking method, right? So such of the methods are known as the hand picking method, froth flotation method, and so on. So here hand picking method means just by the name itself, we are just picking from our hands, picking by using our hands, right? So for example, if you are having any of the two substances which is look alike, right? Which is look alike, we are not able to separate them, right? We are not able to separate them. Similarly, if you are having the metal, I mean ore and the impurities, right? If they are same in size or similar in size or similar in color, we can't separate them each other, right? So this hand picking method is not applicable when both the ore and impurities are look alike. Is there any doubt? Okay, I hope you understand. Okay, now we are moving to our next question. So read the paragraph carefully. Ionic compounds are formed by the transfer of electrons from metals to non-metals, resulting in oppositely charged ions held together by strong electrostatic forces. These compounds are usually crystalline solids with high melting and boiling points. Though they do not conduct electricity in solid state, they do so in molten or aqueous state due to the mobility of ions. Okay, I hope you understand the paragraph. Now we will be moving to the questions based on this paragraph. So here is the first question. The high melting point of ionic compounds is due to. So what will be the answer? It's already given in the paragraph, right? Because of the strong electrostatic interactions or electrostatic forces, they are having the high melting or boiling point for the ionic compound. So option B will be the correct answer here, strong electrostatic forces. Again, here is another paragraph. Read the paragraph carefully. Then we need to answer the following questions here. In metallurgy, right? In metallurgy, ore concentration is done to remove unwanted impurities called GAM. Methods like hand picking, hydraulic washing, and magnetic separation are used. In hydraulic washing, the lighter GAM particles are removed using water current. Magnetic separation is based on the magnetic nature of the ore or impurity. Now answer the following questions. So we have already considered about the metallurgy part, right? So in the case of metallurgy part, first we need to remove the impurities present in the ore, right? Such a method is known as the concentration of ore or ore concentration, right? So in the case of ore concentration, we are removing the impurities. Okay, those who have missed the classes, I am just giving a brief idea here. So in general, we are using some of the methods like hydraulic washing, hand picking, we have already discussed, right? If the ore or impurities are different in size or color, we can just separate them by the hand picking method. Then hydraulic washing, right? Hydraulic washing means we are just washing with the water here, so lighter particle will be go away there. Then magnetic separation, if any of the ore or impurity particle will be having the magnetic properties, we are using a magnetic separation here. So this is the method of concentration of ore. Now we are moving to our question. What is the principle of hydraulic washing? So in the paragraph it is already given, whenever we are doing the hydraulic washing, lighter gangue particles are removed. So what will be the criteria behind that? Options are given here: density difference, magnetic attraction, boiling point difference, and solubility difference. Okay, at least give me random guesses. Options are here, right? A, B, C or D. So option A will be the correct answer here, density difference, right? So if you are having the high dense impurities or low dense impurities, the lighter particle means they will be having the very less density, right? So the lighter gangue particles will be easily washed away by the water current. Gangue particles means impurities present in the ore. Here is our next question. Which method is used when ore or gangue particle is magnetic? So from the name itself, we can get an idea, right? Magnetic. So the separation will be used on the magnetic property, that is magnetic separation, right? So option B will be the correct answer here, magnetic separation. For example, if you are taking iron is a magnetic substance, right? As we already know. So if you want to separate iron from their ore like magnetite or hematite, these are the two ores for the iron. We are using the magnetic separation method. Yes, option B is the correct answer, right? Here is the next question, again repeating the same question. Which method would you use for an ore with visible gangue particles? Okay, I hope you understand the question. Which method would you use for an ore with visible gangue particle? So what will be the answer? Okay, Lian, are you sure it is option A? Options are given here: magnetic separation, hand picking, hydraulic washing and leaching. Okay, but option B is the correct answer, right? Hand picking. As we already know, if the ore or the gangue particles are different in size, right? They are visible. I mean, ore with visible gangue particles. If you are able to separate, if you are able to understand the difference between the ore and gangue particles, you can easily pick up from our hands, right? Pick up by the hands. This method is known as the hand picking method, right? Hand picking method. Just like if you are, which we are using in our homes, right? If you want to remove the stones in the rice, we will be just picking from our hands, right? Picking with our hands. So hand picking method when ore and gangue particles are easily visible. It may be because of the color difference or the size difference. We can easily understand, right? We can easily understand. Lian, is that clear now? Why not option A? Why option B? So again, another question is based on the paragraph here. Read the paragraph carefully. Based on the paragraph, you will get the questions here. In a mining unit, bauxite ore is separated from the red colored earthy impurities. Since both are fine particles and similar in size, hand picking fails. The ore is treated with water current in a sloping tank. The heavier bauxite settle down and lighter impurities are washed away. Read the paragraph carefully. It is asking about the extraction of aluminium, right? Aluminium from the bauxite. As we already know, bauxite is the ore of aluminium, right? We need to separate the red colored earthy impurities from the bauxite ore, but these ore as well as the impurities are similar in size, right? Color and similar in size. So we can't use the hand picking method, right? So the ore is treated with a water current in a sloping tank. Then what is observing there? The heavier bauxite, right? Heavier bauxite. So heavier bauxite settles while lighter impurities are washed away, right? Now we need to focus on the question here. What is the method described here? So what will be the answer here? Yes, option C is the correct answer, right? Hydraulic washing. As we already know, this is the method of washing with the water current, right? So generally it is used for the concentration of aluminium from the bauxite ore, right? So this is the method of hydraulic washing. If you are washing with the water current, right? What you are observing here, hydraulic washing method is having the difference in the density difference, right? So heavier bauxite particles, heavier means more dense particle will be settled down, and the lighter gangue particle, lighter impurities will be washed away, right? Okay, I hope you understand about the method of hydraulic washing, generally used for the bauxite ore. We are separating the aluminium from the bauxite ore, right? Concentration of bauxite ore. Here is our next question. Why was hand picking is not effective? The answer is itself there in the paragraph itself. Why was hand picking not effective? So again, what will be the answer? Option A. Okay, what is the criteria for hand picking? I have already informed, right? I have already mentioned many times. In case of hand picking, whether the ore or gangue particle or the impurities are look alike, we are not able to do the hand picking method. We are not able to separate using our hands. So here both were similar in appearance, right? It's already given here. Okay, since both are fine particles and similar in size, so similar in appearance, the hand picking fails, right? Okay, I hope you understand the answer now. So option C will be the correct answer here, not option A. Lian, is that clear now? Now we are moving to the next question. What is the impurity in this process called? So options are given here: alloy, flux, gangue and slag, right? So there is a specified name for the impurities present in the ores or minerals, right, when we are doing the concentration process. So what is the name for the impurity in that process? So here again option C is the correct answer, gangue particles, right? I have already repeated many times. So it is already given the paragraph also, right? Since both the fine particles are in size. Okay. These lighter impurities are known as the gangue particles. Okay, here is another question. Match the following. Read the question carefully. Match the following metallurgical terms with their correct definitions. So in the case of metallurgical process, we have studied about the concentration of force, right? We have discussed about the different methods like froth flotation method, hand picking method, magnetic separation and hydraulic washing for the concentration of ore, right? Then after concentration of ore, we have discussed about the method of conversion of these concentrated ore into oxide. In that method, we will be discussing about the calcination and roasting. We have already discussed. Then after that, we need to, even though if you are converting them into oxides, we need to reduce it with the reducing agent, right? We need to extract with the reducing agent. So that method is known as the smelting. And after that, we need to do the purification or the refining, right? Purification or refining method. So read the questions carefully. You need to identify the correct definition for their terms. Yes, option A is the correct answer, right? So option A is the correct answer. There is no need to worry, right? It is a direct. Calcination means heating in the absence of air, right? So in the case of conversion of concentrated ore into the oxide, we will be using two methods. First method is calcination, right? Second method is roasting. So what is the difference between these two methods? We are just heating the concentrated ores in presence of oxygen or in absence of oxygen, right? Yes, option A is the correct answer. Okay, next topper shows. I have no idea about your name. So calcination and roasting are the two methods, right? You can just remember like this. The reason O is present in the roasting, right? Which means that this method includes the heating of the ores in presence of air or oxygen. Heating in presence of oxygen. Clear? Then obviously calcination will be heating in the absence or heating without oxygen. Okay, is that clear? So calcination is the heating in the absence of air and roasting is the heating in presence of oxygen. Then what do you mean by smelting? If you want to extract the concentrated ore, we are using some of the reducing agents like carbon monoxide. We have already discussed in our concept classes. So this is a method that is known as a smelting method. And last one, refining. Refining means we are purifying the metal oxides. So if you are doing the concentration of ore, if you are doing the smelting method also, still there will be containing some of the impurities there. So we are doing the final purification. That method is known as the refining. Okay, I hope you understand. Can we move to the next question? So option A will be the correct answer here. Here is our next question. Which combination of statement is correct regarding the limitations of electromagnetic separation? Read the options carefully. Which combination of statements is correct regarding the electromagnetic separation? Options are given here. Only works if either ore or gangue is magnetic. Then ineffective when both components are non-magnetic, cannot be used for fine powdered ores and limited to separating metals from salts. So option A is the correct answer, right? 1 and 2. So it is magnetic separation, right? There is not. This is magnetic separation. So as we already know, if you want to remove the metals or ores from the impurities or gangue particles. Okay, Hassan, after completing the session, just watch our recorded session. I have already given the complete idea about the metallurgical process over there. So just rewatch the sessions there. So only works if either ore or gangue particle is magnetic, right? If any of the gangue particle or the ore particle is magnetic, we can easily separate it by using the magnetic separation. Then it is ineffective, it is not effective when both the components are non-magnetic. Any one of them should be magnetic. So option 1 and 2, I mean the statements 1 and 2 will be the correct answer regarding the magnetic separation here. So option A will be the correct answer. So if you are using fine powders also, it is fine, right? We can just use the magnetic bar over there. It is easily separable. Here is our next question. Which of the following best explains why an ionic bond is formed between sodium and chlorine atoms? So we have studied about the formation of ionic compounds, right? If you are taking any of the metal or non-metal, okay, here, right? What is the statement given here in third statement? Cannot be used for fine powdered ores, right? If you are taking the magnetic separation, we can use the powdered ore also, right? We are just using the magnetic bar over there. So for fine powdered ore will be easily separated there. Next topic shows, I hope you understand now. The statement is given here, cannot be used for fine powdered ores, but it is usable for the fine powdered ores also. Okay. So here is the next question, ionic bond formation, right? This is a special case in the case of sodium, in between sodium and chlorine atoms. So what is happening there? Which one is loss in the electron, which one is gain in the electron, how they are forming the ionic compound. Read the options carefully. So what will be the answer? We need to just focus on the sodium atom, right? Sodium atom, as we already know, it will be metal, so it will be easily lost electrons, right? Then chlorine is a non-metal, it is easily gaining the electrons. So what will be our answer? Sodium loses an electron to attain neon configuration and chlorine gains one electron to attain argon configuration. Is there any doubt? So I hope you must have idea about to write down the electronic configuration, right? So sodium is having the atomic number 11. So its electronic configuration will be 2, 8, 1, right? Which means in the valence shell it will be having 1 electron. So in order to attain the stability, we need to focus on the octet rule. We need to complete the 8 electrons. So it is already 8 here in the second shell, right? So we need to just remove these 1 electron. So the sodium will removing 1 electron to form Na plus ion, right? Na plus ion plus 1 electron. Clear? So if you are losing here Na plus ion, it will be having the electronic configuration of 2, 8, which will be the electronic configuration of neon, right? Neon is having the electronic atomic number of 10. Okay, I hope you understand now. Then what about the case of chlorine? So I will be writing here. Chlorine is having the atomic number 17, right? 17. So the electronic configuration will be equal to 2, 8, 7. Again, here also this chlorine needs to attain the stability to attain the 8 electrons. So what he is doing here, what chlorine is doing here, accepting 1 electron lost by the sodium to form Cl minus ion, right? So Cl will be taking 1 electron lost by the sodium to form Cl minus ion. Now it will be having the similar electronic configuration of argon. Clear? (288), which is the electronic configuration of argon. Is that clear now? Is there any doubt? The same type of question given here. Read the question carefully. An element is given with the atomic number. An unknown element X is given with the atomic number 12 and another element Y is given the atomic number of 8. Which of the following options correctly represents their ion forms and resulting compound? From the atomic number, you will get the idea about the electronic configuration, right? Just focus about the valence electron there. If it is possible to remove those valence electrons, we can just attain the stability. We can just attain the stability of the octet rule. They will form the such type of ions, right? So generally, the metal will form the cations and non-metal will be forming the anions. So please give me answers. Yes, option D is the correct answer, right? How we can solve this problem? X is an element with atomic number 12, right? So as we already know how to write down the electronic configuration. So it will be 2, 8, 2. So in order to attain the stability means we need to focus on the octet rule. Octet rule means in the valence shell it must contain 8 electrons only. So what is present over here? 2 electron is extra, right? 2 electron is extra. So it is losing these 2 electrons. Whenever any of the metal or any of the element which are losing the electrons, they will be getting the positive charge, right? They will be forming the cations. Cations means positively charged ions. So by losing these 2 electrons, X will be forming X2 plus ion. Is there any doubt? Now what about the case of Y element here? Y element is having the atomic number 8, right? Atomic number 8 means it is 2,6. 2,6, it is deficient with 2 electrons. So what it is observing? These 2 electrons will come with the Y to form Y2 minus ion, right? Gaining of electrons means it will be forming the anions. So it will be forming Y2 minus ion, right? Now how they are forming the compound? We are just adding the valencies, right? We are just crisscrossing the valencies here. X and Y, valencies 2 here, crisscross. So it will be forming X2, Y2, or simply we can say that the compound will be XY. Is that clear? So option D will be the correct answer. Okay, is that clear? Here is our next question. Okay, why is bauxite considered a better ore for aluminum extraction compared to other aluminum containing minerals? So what will be the answer for this question? Why we are using bauxite to separate the aluminum extraction, for this aluminum extraction? Why not other minerals? So here again option C is the correct answer, right? So as we already know what you mean by the difference between minerals and ores, right? Ores are the certain type of minerals, they will be containing the maximum amount of the metal present there, right? So bauxite contains a higher concentration of aluminum oxide and allows cost effective extraction, right? This is a main important point for the ores, right? If any of the minerals, we can say that all the minerals are not, yes, option C is the correct answer, right? All the minerals are not ores, right? So some of the ores are the type of minerals in which they contain a maximum amount of the element, right? For example, here in the case of bauxite, it will be having the maximum concentration of the aluminum oxide. That's why we are using bauxite as the one of the ore used for the extraction of aluminum. Okay, I hope you understand. Okay, here is our last question. We need to identify the option, I mean whether it is true or false statement. Statement is given here, all minerals are ores. We need to identify whether it is a true statement or false statement. So what will be the answer for this question? So I have already repeated, right? All minerals are not ore. So this statement will be false, right? Because not all minerals are ore. They are economically viable for the metal extraction, as we already see in the case of bauxite, right? If we want to extract the aluminum from any other minerals, it is not possible, right? In the case of bauxite only, they will be containing the aluminum, right? Aluminum oxide in the many high concentration. Okay, this is all from my side for today. I hope I have completed almost all the important topics in the metallurgy part in the metals, non-metals and chapter. Do you have any doubt in any part of the chapter? You can ask. Otherwise, we can end the session for today. So thank you so much all of you. See you in the next class. If you really like the session, hit the like button and subscribe our channel. Share this particular session to your friends also. So see you in the next class. Bye.